Hey folks, my name is Paul Hudson, and this talk's called OMG Collection Views. If you haven't heard of my work before, I run a site called Hacking with Swift, where there's stacks of free articles about Swift, plus lots and lots of books. In fact, if you go to this URL, the next 24 hours, you can get a free book called Swift UI by Example. Just take a picture, you can get it later on. You've got like 8 seconds, 7, 6, 5, 4, 3, sorry. Too late? Okay, so the plan for today's talk. When you heard collection views, you might have thought, wait a minute, collection views, I've heard of them before. They're from iOS 6. They're very, very old. And in fact, if you look at how Apple introduced these things, you get an idea of quite how old they were, because it was back in Dub 2012. I was in the audience for that one, and the screenshot they showed was this. Oh, look at that wood. It's beautiful, right? You wouldn't get that today. Of course you wouldn't. But Apple said, hey, you can do really cool things as collection view. You can make layouts like this. Wow! Which you've, of course, never seen in real life ever. But when you went back to your office to try this thing out, chances are you actually made something much more like this. And you'd be staring at that large black gap in the middle, and you'd be really annoyed. So you'd go and try and fix it. You'd say, hey, Google, how the heck do I censor UI collection views? Or, why is it so freaking hard to censor UI collection views? And after various manual mathematics, eventually you get something slightly less bad, which is that. But still not great. And at the same time, Apple's making collection views like this one. This is photos in iOS 13. I'm going to hit play, and it will change between days and months smoothly. It even retains the inertia. Watch it again. It's absolutely gorgeous, this collection view here. So they're doing that, and they're doing things like this. This is the App Store. See, on the left here, we have a sort of hero image carousel. You can swipe through beautifully, get a little peek of what's before and what's after. You have, slightly further down, these groups of 3 things on the right there you can pan through, a table below it, all in one big view. So you might think very easily, maybe they're just wizards. They're a whole other plane than us. And then this year, Dub 19 happened. And of course, everything was overshadowed by Swift UI, but Swift UI can't do collection views. So instead, Apple gave us something new, something I've kind of called UI Collection View 2.0. The collection view you always dreamed of. I should say that's not actual Apple's branding. They're not calling it that. It's a huge improvement, though. So I thought, for our plan, what if we could take all the new collection view features and recreate the App Store in about 45 minutes, / 43 minutes, according to that timer. I've spoken for 2 minutes already. Of course, there are some massive provisos for this, right? First up, I'm not going to make the whole App Store, not by a very, very long way. We're just looking at the collection view parts of it. Second, I haven't got any of Apple's source code. I'm basically looking at the thing and saying, well, it's about this much. Basically making a best guess, looking at the screen. And finally, there are going to be some hideous magic numbers to save some time. I've designed to work on the 11 Pro Max. You have to do some more work to make it work on other devices as well. So with that in mind, the code for this will be on GitHub. It'll be a lot of code. Don't try and follow along unless you really like hurting your brain. Let's start off in Xcode. Here's a template app I've made already to jumpstart us here. It has apps sitting here in a simulator. It has 4 empty tabs. That's all. It's a trivial application. The code for that in Xcode over here, the app delegate is the default app delegate. Nothing's changed. Delegate, default. The app view delegate, that's the first interesting thing. The first thing that actually has some custom code, and that's all the custom code there is in there. You can see it's going to decode appstore.json into being an array of App Store sections. It has a collection view. It makes a collection view be full size with a default collection view flow layout. It applies a resizing mask so it stretches neatly in all devices, gives it a background color, and adds it. That's the entire App View controller, basically empty. As for Arcade, nothing, just a placeholder. Games, nothing. Search, nothing at all. Just there to sort of fill up the tab bar nicely. Section, a simple Swift struct, deciding what an App Store section looks like. It has a title, a type, an items array, and so forth. And the items array holds apps. Another struct in app.swift. Has a tagline, has a name, has a subheading, has an image, and so forth. The only really interesting code here is this extension, bundle decodable, which I'll walk you through real fast. It just makes it easy to load JSON files from your bundle that you know are fine. So it'll go ahead and be generic over all kinds of decodable things. It'll find the path for that thing in your bundle, get the data from it, decode it, and return it. And it'll work with any kind of codable thing with no error handling. It's super fast. You know it's fine. It's in your bundle. And finally, this App Store JSON thing. That's our data we're working with. You can see here is a section. It's called a featured section, has no title, no subtitle, but has various items. This one's called Strokey. You'll never stroke the same way again. And there's loads of these things. You can scroll down and see all your items. And eventually, you'll see another section. Down, boom, there we go. This one's a medium table called See in Dark Mode. So there's various kinds of layout. That is our starter app, not a great deal of code. We're going to build everything up from scratch in the next 39.5 minutes, more or less, if I talk quickly. Let's start in the Apps View controller. This thing already on line 13 creates a collection view to work with. I'm going to add some code below to make a new data source of the type UI Collection View diffable data source, generic over our section and our app. That's our two structs. And this thing here, this is new in iOS 13. And it's a way of letting us manage data in a collection view using snapshots. We'll go into snapshots shortly, but it's really neat, because section, that's our data type. App, that's our type, which means this thing understands our model. It'll say, here's your app, what do you want to do with it? Versus us saying, OK, get the index path, read into our array, yada, yada, yada. It'll literally say, here's your app, what do you want to do? Anyway, back to the code. So there is our data source. I'll now make a new protocol to represent any kind of self-configuring cell, a cell that can show an app somehow, called a self-configuring cell. This thing is a protocol called self-configuring cell, cleverly enough. Has two requirements. It must have a reuse identifier string, so we know how to dequeue these things, and a method called configure with an app. That's it. If you're some sort of cell in our app store to configure yourself, you've got to know how to handle an app and to be dequeued from a collection view. With that in mind, we can now create our first collection view cell subclass. I'll call this thing a featured cell. And it's a regular UI collection view cell subclass, nothing special about it. We'll create it in our project. Like I said, this thing will conform to the self-configuring cell protocol. So we can say, here you go, featured cell, configure yourself. To do that, has to have that reuse ID. So we'll say the reuse ID is just featured cell. Now, for its layout, this is what we're trying to match. Small blue bold title, two subtitles below it, and then a head image below that. So we'll define some properties in here. We'll say there is their tagline label. There is a name label. There is a subtitle label, and there is the image view below it. Those four things. We're also going to say, as with all our collection view cells, we want to override the default initializer for these cells, which is init with a frame. So we'll go ahead and write override init with a frame, immediately call strep to super init so it can do its own thing, and then start configuring our layouts. So our tagline font, I'm going to say to font metrics, please give me the scaled font for the system font of size 12, using weight bold, roughly matches Apple stuff, and give this thing the text color of .system blue. Now, the reason for the line 22 there, scaling up stuff, is because I want to use dynamic type. Of course I do, it's great, but you can't modify dynamic type's weights. So we've got to scale up a font by hand to match the dynamic resolution. As for the color, on line 23, we're saying system blue, one of the new iOS 13 adaptive colors. It's no longer the sort of pure blue of old, but it's a sort of paler blue that looks better on dark mode and light mode. Next up, we have our name. This is a regular font. I reckon it's title 2 roughly, and text color is label. This is one of the new semantic font colors in iOS 13, which will be black on a white background or white on a black background. Next up, we have our subtitle. This is also, I think, a title 2. But now, the text color is going to be a secondary label. This is still white and black, but it now applies opacity, so you get a little bit of the background color through it. So in this case, it looks kind of grayish. Next up, our image. I'll say it's got a little bit of rounded corners, like 5 points. It clips the bound, so the corner actually applies. And it won't stretch as content, it does scale aspect fit instead. Now, I'm using clips to bounds true here. My sort of shonky, half-baked images are actually the wrong size because I'm like that, so it won't quite work as well as planned, but you get the point. So we have our stuff now. We'll put all that into a stack view. We'll So there's a UI stack view with the subviews of our tagline, our name, our subtitle, and our image view. And this stack view, I'm going to lay out by hand. So I'll say it's Tamic, which I'll say a heck of a lot in this talk. Tamic is short for translates autotizing masks into constraints. Its Tamic is false. Turn it off. We'll do layout by hand. It's also going to go vertically rather than horizontally, which is the default. And I will add that to our collection view cells content view. As for the constraints of this thing, they're pretty easy. Fill the whole space available. So I'll go ahead and say, there's NS layout constraint, activate a whole array of constraints at the same time. And I'm going to pass in, well, our stack view's leading anchor should match the content view's leading anchor. Then I will just copy and paste that lots of times, because there's no nice way of doing this. And we say our trailing anchor is a trailing anchor, our top anchor is a top anchor, and you get the point by now. Why is there no shortcut for this apple? Boom. And then, just a small little tweak, I'm going to say to our stack view, please apply a little bit of custom spacing of 10 points after the subtitle, because that's more or less, literally looking at it, how the Apple One looks. So that is our featured cell, a cell we can show things in with a picture and title and so forth. We also have to say, configure with an app to match our protocol. This will copy into our tagline, the app's tagline, copy into our name area, the app's name, and so forth, configuring the cell to look right for the app it has to show. It'll do for image, UI image named from the bundle, because I don't want to do image downloading here. I haven't got that much time, quite frankly. And finally, it is required when you subclass collection view cells, you've got to implement required init with a coda. Don't do that here, I haven't got time for that. Let's do fatal error, not happening. We're not doing that here. That will, of course, just crash your code. Just don't do it. OK, there's our cell. Now we can head back to our apps view controller. And we're going to write a method here that can dequeue and configure any kind of self-configuring cell. So I'll call it configure, generic over self-configuring cell. We'll say, here's the app to show and the index path to show, and return the cell. But it's generic over that protocol we designed. So anything that conforms to a self-configuring cell can be used with this. All we're going to do is give it the app and the index path, and it'll give us back the fully configured cell ready to show. So inside there, I'll say, first, well, let's go ahead and dequeue a reusable cell from the collection view using the identifier we usually expect. We know we have one thanks to our protocol. For the index path we passed in, and do a typecast as the type we thought we'd get. If that fails, again, just fatal error. This one actually is justifiable, because if you haven't got a collection view cell in your code, that's a real logic error. Configure with the app we provided, and return it. So this can now handle any kind of self-configuring cell, dequeue, configure, return, instantly like that. So now we can start using it. In our collection view, we're going to register that cell class, so we can start dequeuing these things with its type and its reuse ID. Boom. Next up, we have to get our actual data. A new method called createDataSource. This will go ahead and make a new data source type here, your UI collection view, different data source, again, section and app. But it'll pass in our collection view. It will own our collection view. So it will know how to configure that in the future if we ever make changes, adding and removing things. As we pass the collection view and the index path and the app itself into the closure. We haven't got to worry about, oh, where's my data saying, what should I look up, and so forth. It will literally say, here's the app to use. What do you want to do with it? It knows how our model works now. So we can say, we're going to look at our section type. And for now, no matter what's the default type, we'll just go ahead and do self-configure with our featured cell and that app and that index path. So no matter what kind of cell we get, no matter what kind of section we're in, always use a featured cell. And last, another method down here. How do we load the data into our table view? Here, we'll use a new type called an NS diffable data source snapshot. Again, generic over section app. This is new in iOS 13, and it's remarkably useful. This allows us to hold all the data for our collection view, visible or otherwise. We put it all in there and let it decide what gets shown and when. So we fill this thing full of sections and apps, wrap it in a snapshot, and apply the snapshot, and boom, it's in our collection view. When you make changes, make another snapshot. Remove things you don't want anymore. Apply that snapshot, and it will animate the changes automatically. It's really, really nice. So that's a difficult data source snapshot. So we've made one here, and we're now going to go ahead and fill this thing with all our sections. Here you go, have them all. And then loop over all the sections and add the items to those sections as well. So it has all the data for our entire collection view up front. And we can now say, apply that to our data source, which in turn will show it in the collection view, because it knows what a collection view is. So that's our data ready. And with that in mind, we can now go up to view to load and use them. We can say, create the data source up front and reload the data. Inject our initial data into the collection view. And now we can go ahead and run the code and brace yourself for the amazing results. Yay! Now, doesn't look a great deal like that, to be fair, but that's not surprising. So far, we've looked at how we manage data in our collection view. What are the sections? What are the items in our collection view? And that's done by our diffable data source. What we haven't done is manage how that should be shown. And right now, we have a UI collection view flow layout. That thing, the wood grain, which results in this sort of hideous, blocky, square, white thing. We don't want that. So we're going to rip out UI collection view flow layout and replace it with another new type called UI collection view compositional layout, which is significantly better. And it gives us a number of new types to work with: an NS collection layout size, an item, a group, and section. And they all have NS collection layout in common, so let's remove that bit and focus on what remains. Size? Easy. How big is this thing? Fine. Item, group, and section all are more complex. Here's our App Store again. Let's trim it down slightly. Remove everything but this part here. Get rid of the bezel, and imagine how this looks behind the scenes. It's kind of panning off across the screen, which you can just swipe through in a scroll view. In a compositional layout, this thing here, one of these things, is a layout item. One item in your collection view. The vertical stack that move together, that's a group you've defined. 3 things. And that group belongs to a wider thing, which is a whole section. So, one or more layout items goes into a group. One or more groups goes into a section. One or more sections goes into the compositional layout. Now, sometimes, as in our picture at the top here, actually groups aren't really needed. They're not really doing very much. You still have to have them, but there's basically a shim between items and sections. So back to our code. What should a header look like? What's a header section to us? Back in our code, we can define a new method. We'll call this thing create a featured section using a section, and return the NS collection layout section that's been made. And I'll start off by saying, well, what is our item size? How big should an item be in this? So I'll say this item size is a collection layout size, and it takes 2 parameters, a width and a height. For the width, I'll say a fractional width of 1. And for the height, a fractional height of 1. That means 100% of my parent's size. Fill my parent completely. We can now wrap that in an item. The NS collection layout item, passing in that item size. Again, there's no content here. This is just layout we're looking at. Next up, what's our group size? So we can say our layout group size is another NS collection layout size. Again, these 2 values. For the width, I'll say fractional width, again, of 1, 100%. For the height, though, I don't want to fill the full screen. Shouldn't fill the whole section. That'd be odd, right? Instead, I'll give this a rough estimate. This is approximately 350 points. Not exactly, but start with that to get the layout working now and change as auto layout figures out later on. We can now wrap that in our layout group. And this thing, I'm going to say, is going to go horizontally. That's what we expect to happen in this particular layout. For the size, it's going to be our layout size. And our items, that's our layout item. That's our item, that's our group. The next one up is a section. So we can scroll down, make some space, and say our layout section is an NS collection layout section with that group. And there's nothing special happening here. I'll just go ahead and return that section straight away. So that's how a header section should look in our collection view. Now it's time to create the actual collection view layout itself, where it decides which sections to load and when. So make another method. I'll call this thing create compositional layout. And I return a new UI collection view layout. And inside there, we'll create a new constant called layout using the UI collection view compositional layout initializer, which takes a closure, the section index that we're looking at, and a layout environment. And then this will get called whenever the layout environment changes. Like if you go from horizontal to portrait, landscape, for example, portrait to horizontal, vertical to horizontal, there we go, portrait to landscape, then your layout environment's changed. Should your cells change size? Should you show different things now or not? It's down to you. It's really, really useful to have that. Anyway, inside here, I'll read out our section type and say, let's look at what we have. And for default case again, just show another featured section for that section. As our default case, just make it that nice big scrolling image carousel layout. Just below that, I'm going to add one small tweak. I'm going to add a configuration for our collection view using the world's longest type name. I won't even read it out, it's pointless. I'll say this thing has some intersection spacing of 20 points, a bit of spacing between sections, and use that for our layout. And that is our layout complete. We can now go back up to view to load here and switch out our flow layout and instead call create compositional layout. Use our new layout instead. And with that in place, we can now run the code again and see some immediate results. Get in there slowly. There's our big picture. We're going to scroll down the way, which isn't perfect, but you can see at least it's vaguely working. So it kind of works well. Get in there slowly, right? Now, why is it doing that? We really want a horizontal thing. In fact, we asked for a horizontal group. Why is it giving us that? Well, back in our code again, if we scroll down so we make the header view, we can see we're using fractional width of 1 for our group. The group should be the full width of the section. So it'll take up all the space in the screen. We don't really want that. We want to scroll horizontally. So I'll say our layout section has orthogonal scrolling. It scrolls relative to the major scroll view in a different direction. And there are a number of options here, continuous, group paging, and so forth. Here's how they look. Here is continuous scrolling. Works much like a UI scroll view would work. You pan around, release, it'll just float naturally to a stop and sit there. That is continuous scrolling, as you'd expect. There is continuous group leading boundary. Again, you swipe around. When you release, it will automatically come to a halt, so your group starts on the leading edge. Exactly right every time. It looks gorgeous. Really, really nice. Then we have group paging. Now it will page by the size of your group. So we'll always make sure our thing starts on the left edge, one page at a time, every time. Then we have group paging centered. The same thing, but it now offsets slightly so your item's always in the middle of the section. So you can now see things hanging off the left and the right. A preview that there's more to come or more behind you. And there's paging, which goes by the whole width of the screen or your collection view every time. So in our layout here, it just gets worse and worse as you get further and further through it. Probably not going to use that one as often. Anyway, here I'm going to use group paging, centered, so it stays in the middle. And now we run the code again, we'll see this thing starting to come together. There's our layout. I can now swipe through to see things. It's getting there. It's not ideal, but it's getting there. To make this better, we can go back to our code again and change our width to a magic number of 0.93. Again, epic shortcut. That's me trying out various numbers to try and guess what the App Store uses. Don't be full width, be slightly less than full width. And I'll get this kind of layout. We can now see things on either side, peeking behind and ahead. It looks way nicer. We can also add some spacing to that. We can go to our layout item and give this thing some content insets. Using NS directional edge insets. For the values, I'm going to say there's 0 on the top, there's 5 on the leading, 0 on bottom, and 5 on trailing. So a little bit on the left and right edges, just a little bit. And the result is that. pretty much exactly how the App Store does it. So that looks really nice. Now, it's not perfect. If you look at the App Store, and I'm not sure how well it is on the cinema screen with the lights up, if we zoom in really, really close, you might notice there is a super thin gray line. We can do that. Yeah. Back in our code again, we can simulate that by going back to our featured cell, scrolling up to our override initializer, and it's below there, making a new view called separator, using a 0 frame. I'll make sure and turn off Tamic so I can futz with it by hand. And I'll give this thing the background color of .quaternary label. Lovely. That basically means pretty much invisible white or black. You know, like 20% opacity or something, really, really low. We can then add that to our stack view, our separator, before the tagline. And then, in our constraints, I'm going to add a constraint here, making it exactly 1 point high. Because it has nothing in it, it'll collapse to 0 where possible. I'm saying, no, it's got to be exactly 1 always. I'll also add a little bit of custom spacing underneath again, just to match the way the App Store does it, more or less. And after we run the code again, good luck seeing this, you'll see a tiny little gray line at the top there. Yes, that was worth 2 minutes of my time. But even better, because we've used these semantic colors and system colors and more, if we go to the Settings app, scroll down to Developer, and click on the switch saying Dark Appearance, our app will look great out of the box. We'll get the right shades of blue and black and white across the board. It just looks great. So, what we now have, as you can see, is that first section done. Hurrah. Easy peasy. The next one is going to require some more thinking. But on the flip side, it uses nearly all the same code you've already seen. However, as you can see, it has those 3 things there going vertically, so it'll hopefully let you see why those groups are so important. Let's go back to the code. And in Xcode again, I'll go ahead and make a new collection view cell subclass called a medium table cell. Yes, go ahead and press Next and create in the Tap Store project. This will be another self-configuring cell conformance, which means, of course, in turn, it has to have that reuse ID so it can dequeue itself. Now, for the layout of this thing, we want something that's very much like this. It has an image, it has a large title, a small gray thing below, and a button on the right. I'm not going to do get, download, open, just a single button on the right is fine. So we can say, first we have our name label, then our subtitle label, then our image view, and then our button. I'll use a custom button type. So those are 4 views we're going to show. And as before, we have to override that init frame initializer, passing on that frame straight to super so it can do its own thing. And then we'll start configuring our properties here. We can say our name has a preferred font size of headline and the color of label, like before. Our subtitle, more or less, I think, is the font using subheadline and a text color of secondary label. So it's a bit gray. Below that, we have, of course, our image view. So I'll say our image view has some sort of corner radius. It's nicely rounded. It's more this time. It clips to bounds nicely. And our buy button, I'm going to add an image here using a particular system name, which is going to be iCloud.and.arrow.down. Brilliantly named. For the case normal. Now this thing here, of course, is a new iOS 13 thing. This is SF symbols. We get Apple's 1,500 symbols for our apps now, free of charge, which is beautiful. And other stuff there. And now that thing's going to a stack view. Our inner stack view will contain just the text bits, the name and the subtitle. That's the inner stack view. We can then take that and say, well, you have to go vertically because you're going above each other like that, up and down. And you're going to go inside a bigger stack view. So there's going to be an outer stack view with the arranged subviews of the image on the left, then our inner stack view, then our buy button on the right. And that stack view, this thing will have Tamic off, of course. We can futz with it freely and add that to our content view. As for the constraints, again, terrifically boring. Go and file a feedback, ask for a better way of doing this. An array of stuff. Our stack view has a leading anchor equal to our content view's leading anchor. There we go. Then copy and paste that rather than making you wait. Boom. So it's the trailing anchor and the trailing anchor and a top anchor. The bottom anchor is irrelevant. It'll just squeeze the fit automatically. So there is our constraints. This thing has to know, of course, how to be configured with an app. It's part of our protocol. So we'll put the app's name into our name, the app's subtitle into our subtitle. Our image view show the app's icon. Again, loading from the bundle because I'm being lazy. And sigh, we've got to put init coder once again, silly thing. I'm not supporting it here. I was happy to do a fatal error again. Just no, ain't happening. So you can't use storyboards. So there is our new medium table cell. So now back in AppViewDelegate again, we want to go ahead and start using this thing. So step one, go to our collection view and register that class alongside the existing class. We'll call register for the medium cell self type with its reuse ID, like that. Boom. And of course, we want to use this inside our data source and so forth. So down here, we have our section type switch. I'll add to that, if we're a medium table, then use the configure with our medium table cell instead. Otherwise, everything else, go back to the featured cell instead. So that is our data source all set up nicely. Now it's time to show the heading, the layout in a compositional layout. So I'll make a new method here called create medium table section. Takes a section, returns another section layout, ready to use. And here, again, I'm going to make an item size and so forth. So I'll say, well, our item size, another collection layout, item size, and so forth. And this time, our width is going to be a fractional width of 1, so full width of this group we're in. But the height, remember, there's 3 of these in a group. The height's going to be fractional height of 0.33. So a third of the available height in our group. We can now wrap that in an item. Boom, the size. And then I'm going to add the same inset I had in the other thing, so it sort of matches it nicely. That was, remember, top 0, leading 5, bottom 0, trailing 5. And that's our item. Below that is our group. So this thing is an NS collection layout group with size, this time, the width, easy, fractional width of 1. It's a full width of the screen. Well, 0.93 because of my magic numbers, but the full width of the screen. The height dimension, how big should this thing be? In this case, I'm going to say fractional width of 0.55. Now, you might think, why have we got width, width, and height, width? That makes no sense. But actually, it makes remarkable sense. Look at the layout here. Here's a big container with a cell inside. If you want that cell to be the full width of its container, you might say width 0.5 of the parent width. But how do you say, once it fits nicely, how do you say be a square? What height would you use for that? Easy. 0.5 width. And it'll figure out what you mean. Now here, it's really not a good idea. I'm just doing it specifically to show you how it works. You wouldn't want to use this exact case in your own work. But it's cool. I couldn't resist showing you. Anyway, fractional width 0.55. And then wrap that in our layout group. Using the collection layout group of that thing, going vertically now with that size and our single layout item. After the group, of course, comes the section, the next thing up. They can use section, wrapping up that single group. Like that. I'll give this thing orthogonal scrolling behavior of group page center to match the previous thing, and return it all. Like that. And now we have that method in place, we can scroll up to where we make our layout and say, now, if we're loading a medium cell type table thing, fine, create a medium table section from there. Otherwise, use the featured section type. Like that. And when the code runs, we'll see something sort of correct. There we go. That thing on the bottom there, you can see it sort of works, but it's kind of being warped. What's happening here, of course, is our stack view. It's saying, well, I've got this space, I've got 3 things, I know I'm going to stretch the worst possible thing. What we really want, of course, is for that not to happen. We want to stretch the stretchy thing, the label, and leaving some blank space in there. Fortunately, this is trivial to fix. Back in our code again, we can go back to where we made the medium table cell, And when we make the buttons and so forth, we're going to add 2 extra lines of code beneath the by button. We're going to say our image view has a custom content-hugging priority of high horizontally. Stick to its container. And the same for its by button. Wrap tightly around whatever it has inside it. Those 2 things. And as a result, what remains is the text label. So it will now be stretched freely inside the stack view, like that. So it looks kind of better. Not great, but better. Look here. There's big space in these labels. Not very nice. We can do better than that. Stack view can do better than that. Back to our code again. We can say, well, actually, this outer stack view, what you want to do is have the alignment of center. Don't stretch them out. Just make them align in the center if they don't quite fit. Run it again. Now we see the labels are sticking neatly together. Looking quite nice. But look at this. No spacing there. Looks pretty grim. Again, easy stack view fix. Back in our code, we can say our outer stack view has default spacing of 10 points between all the items. Run it again. And boom. We have something looking remarkably good. So that is our second section, looking really, really nice. Or is it? Here's the App Store's version. What happened to this title? Now, that thing doesn't scroll. That's fixed in place as the group pages around it. So we've got to do some extra work for that. Back in Xcode, I'll make a new subclass of UI Collection Reusable View. That's headers and footers. I'll call this thing section header, and make it in our project, yada, yada, yada. Great, it's fine. I'll give this thing a reuse ID string so I can dequeue it nicely. I'll just call it section header. And this one's trivial. It's got a title and a subtitle. That's the entire thing. 2 simple labels. So here I'll say there is a title label and there is a subtitle label. Nice and easy. Of course, we have to override the same initializer as before. Init frame. Pass it up to super nicely. Now for this thing, I reckon we're going to say first our little separator. So 0 frame, turn off Tamic, give it the fancy pants quaternary label background color. Easy. And that's the same thing we had in our featured cell, identical code. Our title, I'm going to say this thing is label. I have a font. I've got an exact font again. It's scaling up the system font of size 22 with a bold. It's been literally hours of me staring at a screen to get the right size of stuff. Like that. And for our subtitle, that's going to be a secondary label. Boom. So those are our entire views. As you might imagine, we have to go ahead and make a stack view of those things so they look nice. This thing has the arranged subviews of our separator, our title, and our subtitle. And it's going to go ahead and turn off Tamic so we can do layout constraints by hand and go with a vertical axis. Boom. And then we'll go ahead and add it to our subview directly. And then write some beautiful layout constraints. While that's happening, what's orange and sounds like a parrot? A carrot. Bit of time, that one. Oh, she gets it. So there's some constraints, copy and paste, yada, 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 just as before, trailing, trailing, and top, and top, and bottom, and bottom. You can see why folks use alternative wrappers for these things. Anyway, like that. I'll bring it a little bit off the bottom by 10 points, because that's what the App Store seems to do. It's very, very similar. Like that, and I'll add the same custom spacing directly below the separator. Boom. OK. Now, as this is subclassing a UI view class, we have to go ahead and have the init coder once again. Never use these things, never want to use these damn things. Fatal error across the board. I never want to see these things. Stop it. So crash. So that is our, yeah, there is our stuff. We can now go ahead and add that to our collection view. We can go ahead and register that thing by saying this thing, register as a supplementary view, a header or a footer. Like this, I'll say go ahead and register our section header. The view of kind is really precise. It's like UI collection view dot element kind section header, and our ID is section header dot our release ID. Boom. So we now dequeue these things or create them freely. Then down we make our medium table cell. We have to describe this layout. Hey, you've got a section. So in here, in this gap here, I'll decide what a section looks like, a header. It has a header size, and it's another layout size. With the width, I'm going to say again, is a fractional width of magic number, 93%. For the height, approximately 80, basically my best guess. We can then put that inside a section header, which is an NS collection layout binary supplementary item with that size. And the element kind we'd expect, which is, again, UI collection view dot element kind section header, aligned to the top. Boom. And then after that, all being well, we can say this thing belongs to our layout section as its boundary supplementary items. So when you're showing this section, show this header attached to it. OK. With that done, finally, almost through the same thing here, we've got to go back to where we make our data source, here in create data source. This thing knows how to dequeue rows. We've got to teach it how to dequeue headers. And it's really, really similar with a bit of hacking and working around. So we'll set a property on our data source, which is called a supplementary view provider. It's another closure, and it'll tell us, here's your collection view, here's the kind, here's the index path, what do you want to do with that? And here I'll say, first, let's make sure we can actually get a header out of our collection view. Pull it out, try and see what it is, make sure it actually works. So our kind was, of course, our section header kind, section header reuse ID, and for that index path. Pull it out and typecast it. If that fails, which should never, ever, ever happen, I'll return nil, which will crash your app. You shouldn't return nil from this thing. You've got to return actual value. But if you can't typecast your own thing, you've got a real logic error. After that, some hackery. We're going to ask for the first app in that section. We're going to say, hey, data source, what is the item at that position? And it will say, oh, it's this app here. If that fails, return nil. Again, crash. Once we have that app, we're going to say, what is the section of that app? So we can ask our snapshot directly, hey, what section owns this app? And it'll tell us. Put that in there. Again, return nil if it fails. And then once we have that, we'll do one last check, make sure we have some sort of title. Again, otherwise return nil. Otherwise, it shouldn't even be here, right? And finally, we can say section header title is our section title, and our header subtitle is our subtitle, and send that thing back. So that creates and configures a section header nicely. OK, at this point, we can now run our code again, and we should see our headers looking nice. And that thing stays fixed as you scroll around. Below it, as the group moves, it looks really, really nice. Just like that. Brilliant. OK, so number 2, done. Hopefully getting easier. Number 3, you should find trivial. Because it's pretty much the same code again. Yes, the layout's different, but not dramatically different. It's a single table now. Back in Xcode again. We can go ahead and make a new collection view cell subclass. So it's UI collection view subclass. And I'll call this thing a small table. Just a picture and a title next to it. Again, it'll conform to the same protocol we had before, our self-configuring cell type, which means it's got to have a reuse ID string, just like before. For its properties, only needs 2 of these things. It needs some sort of name label and some sort of image view around it. Then our old pal, the override initializer with the frame, pass it on to the superclass to work with. And inside there, we're going to start by saying, well, our name for the font is roughly a title 2 again. And the text color is label, of course. It looks good in dark and light mode. Our image view has, again, some sort of rounding attached to it, about 5 points, and it clips the bounds. And that's our layout, pretty much. We can take those 2 things immediately and add them to a stack view with our image view and our name. The stack view will have no Tamic again, and we'll add that to a content view. And I think one last time, let's do some auto layout constraints. This is when you really miss Swift UI. All goes away. Absolutely beautiful. We're going to say our stack views, leading anchor, single anchor, all the usual stuff. Love it. What do you call a fish with no eyes? A fish. You've got to have a quite high-level English experience to get my joke, sorry. So we have leading, top, and bottom. It will resize the field automatically. Boom, that's our small table cell. And of course, we want to use this thing. And so, hopefully, below it, thinking very carefully, laptop, you can do it, laptop. Yeah, you can do it. There we go. Oh, that failed entirely. OK, we can now add our coder, NS coder, like that. Just fatal error. Look, just please, give up. It's not going to happen. We're never going to do these things. No, no, no. OK, so that configures our small table cell. We can now use that back in our app view controller. So way up again, we'll go ahead and add that to our registration list. We'll say collection view, register a small table cell. Using the ID, like that, so it now can be DQ'd correctly. And then down in our data source, we'll say, well, if median table do this, if it's a small table, go ahead and call configure with a small table cell.self. Nice and easy. At the index path. And for the layout, how it should actually be laid out on the screen in the compositional layout, make another method. We'll say this thing is called a create small table section method. Again, returns a section. Like that. Again, make a size for our items inside it. So our item size this time, we're going to say it has a fractional width of 1, fill the group, and a fractional height of 0.2, because if you remember, there are 5 of these things in a group, so they take up enough space for itself and no more. Add that in an item around it by passing in that size to an item. Like that. Then for the group size, this thing is another collection layout size. The fractional width of, we're going to say again, the magic number, 93%. Height is about 200. It's an estimate. Put that inside a group. An NS collection layout group. Boom. This time going vertically with our item at size. Like that. Awesome. So that's our group. Moving on from that, of course, we have our sections. So we'll say our layout section. Here's an NS collection layout section. Hopefully this is like second nature to you now for that group. But this thing needs to have headers. And I could just copy and paste all the code. Not quite so nice. So instead, I'm just going to grab all that code, like more or less that, and put it on the pasteboard, and put that into a new method they can both call, called create section header. Give us a reusable header we can then configure. So down here, I'm making the method, create section header, returns inexplicably long type name. Boom. Paste it all in, and return that thing. Brilliant. And then, with that in place, we can call that same method, take those 3 lines of code, and put that into our small table section. So we're reusing the header functionality, because it's exactly the same on the App Store. Like that. Boom. OK, so the section now understands headers. And with that in place, we're kind of getting there. We now have to go up and find where we make our layouts and call that new method. If we have a small table, call that create method for our layout, the section. And now, all being well, we can run the code and see how this thing looks. It's not far off for a first try. You can see it's a little bit stretched again, spaced quite badly. The fixes are very, very similar here. If we go back to our small table cell again, we can say to our stack view, actually, please don't align stretch, align centered, and apply a little bit of spacing. It's about 20 points here, approximately in the App Store. Run it again. It'll look much nicer already. You can see it's put to the left. This is because our magic number, 93%, does not work here. We're not using group paging centered anymore. This thing doesn't scroll anymore. So instead, we have to apply some content insets by hand. So go down and find our section way down here. And just about there, I'm going to say this thing has some content insets. Again, time-saving magic number. I'll do top 0, leading 20, and 0 and 0. Basically, it's right given the time I have. Run the code back again, and we should see, all being well, the layout looking really nice. OK, phew. So, wrap up. Not bad, quite frankly, 45 minutes, given there were quite a few explanation slides in there and so forth. Given that it's mostly me guessing sizes and spacings and font size and so forth, you could do closer, of course you could, but given the time I have, that's pretty darn close. But I have only scratched the very surface of what this stuff can do. It's way more powerful than I've shown you here. It is absolutely remarkable. You'll never want to go back to a flow layout ever, ever again. Go and watch these two Dubber videos from this year, Advanced in Collection View Layout, which is session 215, and Advances in Data Sources, session 220. Watch those two, and your mind will be blown. One more thing, I know Apple engineers never get to take credit for their work, but I want to say that Steve Breen gave both those two talks, and he is absolutely at the center of this functionality. He's done remarkable work. If you use it, if you love it, if you're impressed by it, follow him on Twitter. Tweet him. He's just __ Brino on Twitter. Go and say hello. Go and see you love his work. I'm sure he'd really appreciate it. Thank you very much.